Before JDK8, the interface type could only have public abstract methods. JDK8 introduced the default and public static methods, and JDK9 introduced private methods, both static and non-static. All of these new method types on an interface are concrete methods. If you didn't review the last videos on interfaces, make sure you download the code from the previous video from the resources section so that you can follow along. In the last couple of videos, I created 3 interfaces: Flight Enabled, Trackable, and Orbit Earth. I also created classes records and enums that implemented 1 or 2 of these. Let's now consider what happens if we learn about a new requirement for flight-enabled objects. A new method is needed, called transition, that uses the flight stages enum type we set up. I'm going to add this method to the flight-enabled interface, which I've declared in the animal.java source file. This method takes a stage, one of the enum values, and returns another stage because it's transitioning from one stage to another. Flight stages transition with a flight stages enum called stage as the parameter. All I did here was define a new abstract method on this interface. Unfortunately, this one change means every class that implements this interface won't compile. This means that for us, Bird, Jet, Satellite, and Dragonfly all have to change. This is painful, and we've only got a small set of classes. Imagine facing this kind of change in a production environment. If you'd publish this interface to be used in multiple applications, making this kind of change wouldn't go well for anyone using it. Your updated interface wouldn't be backwards compatible. Before JDK8, you didn't have a whole lot of options for making changes like this to your interfaces. You either had to force all classes implementing it to be edited so they'd compile, or provide an alternate interface with the new functionality. Java came to the rescue with a feature officially called the extension method. An extension method is identified by the modifier default, so it's more commonly known as the default method. This method is a concrete method, meaning it has a code block and we can add statements to it. In fact, it has to have a method body, even if the body is just an empty set of curly braces. It's a lot like a method on a superclass because we can override it. Adding a default method doesn't break any classes currently implementing the interface. Let's switch back to the code, and I'll switch to using a default implementation for this new method. I'm going to remove that single statement for the abstract method and replace it with code for a default method. I'll print out the class name and return null. In the body of this method, I'm printing the text transition not implemented on and the class name. It's common practice to write a statement like this or throw an exception to confirm that a default method isn't implemented. This means I really want every class using this interface to override this method before they actually use it in code. I can't force them to implement their own version like I could if it were an abstract method. What I can do though is either cause an error or print a statement like this so they'll implement it when they actually are ready to use it. The other thing I want you to see here is that I'm using this .getClass.getName. By now, you know this will give us the class name of the instance, but this is really something new for an interface because an interface isn't a class and an object is never really an instance of an interface. You may not even have any idea when we create an interface what an object executing this method will really be. It could be anything. The Java developers worked their magic and now give us the ability to access a runtime instance from this method. Normally we wouldn't use the explicit this keyword in a class, only in a setter or constructor, as I've previously talked about. I can remove this because it's implicit in non-static methods, including this default method on an interface. Next, I'll create a new class called test in the same package because I want to keep the main class the way we left off in the last video. I'll add a public static void main method in this class, and I'm going to copy the inflight method from the main class and paste it into the test class. I want to insert a call to the transition method between takeoff and fly. Going back to the main method on the test class, I'll call the inflight method and pass it a new instance of the jet class. I want to run this code, but I have to be sure to run the main method on test class and not main class. You can now see the message transition not implemented for dev.lpa.jet on the second line of the output. This means that in this case, Jet didn't override this method. If you really want your default method to get implemented or overridden on every class, you'd want to code something like this in the default method. If I didn't want this to happen, and I probably don't, I have to go to the jet class and override that method. Before the closing class bracket, I want to generate an override method for that transition method. That gives me the default overridden implementation. This looks a lot like what we'd see if we overrode a class's method, except the keyword super here is qualified by the interface type flight enabled. This means the default method on the interface type gets called. That's not what I want either, because that's what happens if I don't override the method at all. I want to change the code in my overridden method. I'll print something out and return a different stage. Here I'll print the class name with a string literal, and then return an enum constant. Before I run that, take a look at the little icon in IntelliJ, comparing it to the one next to the previous method track. There is a green circle with an I and a red arrow next to the track method versus a blue circle with an O and a red arrow for the transition method. The green icon indicates we're implementing an abstract method, whereas the blue icon implies an override, even though we use the override annotation for each. This is one small way to differentiate between these two types of methods in IntelliJ. Time to run this code. The output confirms the new method was executed because we see jet transitioning. I could have been nicer and provided a better default implementation. In some cases, the default method on the interface can be used much like a class method, providing some behavior that'll work for all classes. Just like overriding a method on a class, you have three choices when you override a default method on an interface. You can choose not to override it at all. You can override the method and write code for it so that the interface method isn't executed. Or you can write your own code and invoke the method on the interface as part of your implementation. Let's look at this in some code. First, I'll change the transition method on the flight-enabled interface to have something other than the unimplemented statement. But even before I do that, I want to first add a method to the enum type that gets the next stage. I'll declare it as public returning flight stages and I'll call it getNextStage. Next, I'll create a flight stages array and set it to the array returned from calling the values method. And finally, I'll return an element from the array. With this code, I've purposely avoided using any of the enum constant values like grounded or launch. If the enum constants change and more are included, or some are moved around, I still want this method to work. Firstly, I create a local variable, allStages, which gets assigned the array of enum values that we get back from the values method. I want to return the next stage, which is the stage at ordinal +1 in every instance, except when the current stage is the last enum constant data collection. In that case, there is no next stage, so I want to return the first stage. The second statement looks like a complicated expression, but it's one you should be able to figure out. The expression uses the modulus operator to return ordinal +1 in every case, except when ordinal +1 is equal to the length of the array allStages. In that case, it will be 4/4, as the constants list stands now, with a remainder of 0, and it will give us the first stage. What I'm really doing is cycling through the stages. I want to use this method in the default transition method on flight enabled. I'll comment out the statements in there instead. I'll print some text out and then return the next stage. Flight stage's next stage equals stage.getNextStage. Print the stage transitioning from and transitioning to, and return the enum constant. Since I overrode this method on the jet class, I want to invoke this updated default method from there. Going back to that jet class and the transition method, I'll return the next stage I get from flight enabled's default transition method instead of the hard-coded cruise stage. And here you can see I'm using flight-enabled.super.transition. If I tried to use just super, I'd get a compiler error. Let me show you what happens if I do that. IntelliJ gives us the message cannot resolve method transition in object, which is the jet implied superclass. That's because no class in jet's hierarchy has a method called transition. Remember, interfaces aren't classes and aren't really a part of a class or the object that gets created from a class. They're just a way to make your class and object behave a certain way. I'll revert that last change. Whenever you call a default method from an overridden method, you need to qualify super with the interface type. I will run this code now. You can see that jet is transitioning and it's going from the launch stage to the cruise stage. That's how a default method works on an interface. Java introduced it to help with building extensible and backwards compatible interfaces. In the next video, I'll talk about public static and private methods on an interface and why and when to use them. I'll see you in that next video.